Elon Musk just revealed Falcon 9 rocket is approaching the moon after 7 years in space. Elon Musk has an ambitious goal of reaching Mars one day, and that day might not be that far now. Although that's not the only mission he is on, Musk also employs the Falcon 9 rocket to carry out his several missions. He launched the Falcon 9 7 years ago as a test flight, but it is now soon to approach the moon. The Falcon 9 rocket's second stage had reached such altitude that it did not have enough fuel to return to Earth's atmosphere. It also lacks the energy to escape the gravitational pull of Earth-Moon system, thus it's remained in a fairly unstable orbit since February 2015. The orbit of the expanded second stage is now on schedule to cross with the moon. Want to know more about it? Then stay tuned in the video. Welcome to Elon Musk Exclusive, and before we start our ride, don't forget to subscribe to our channel and press the bell icon to never miss any videos on such exciting topics. That being said, let's begin! Falcon, a family of 3 launch vehicles, Falcon 1, Falcon 9, and Falcon Heavy, manufactured by the United States firm SpaceX with funding from South African-born American entrepreneur Elon Musk, Falcon 1 could carry a 1,000-kilogram payload into orbit for less than the cost of other launch vehicles. Falcon 9 was planned to compete with the Delta family of rockets by carrying payloads weighing up to 8,300 kilograms into geostationary orbits. Dragon, a spaceship intended to transport personnel and cargo to the International Space Station, is one of the payloads it sent into low Earth orbit, ISS. Falcon Heavy's first stage is made up of the first stages of 3 Falcon 9 launch vehicles linked together, and it is planned to lift 53,000 kilograms to space. Falcon 9 is a potentially reusable 2-stage, 2-orbit, medium-lift launch vehicle developed and built by SpaceX. The most recent version of the first stage may return to Earth and fly several times. SpaceX Merlin engines power both the first and second stages, which uses cryogenic liquid oxygen and rocket-grade kerosene (RP-1) as propellants. The name is inspired by the fictitious Star Wars starship, the Millennium Falcon, as well as the rocket's first stage's 9 Merlin engines. The rocket went through several iterations from 2010 to date, which includes the version 1.0, version 1.1, and version 1.2 full thrust, and it also includes the Block 5 full thrust variant, which has been flying since May 2018. Unlike most rockets in operation which are disposable launch vehicles, Falcon 9 is largely reusable with the release of the full thrust variant, because the first step works on the concept of vertical takeoff and landing, VTOL. This accomplishment was achieved for the first time in December 2015 on Flight 20. SpaceX has successfully landed rockets over 100 times since then, with individual first stages flying up to 11 times. Let's take a look at the history of Falcon 9. Elon Musk announced on December 3, 2003, during the Falcon proto-vehicle unveiling ceremonies in Washington, D.C., that SpaceX planned to follow up Falcon, then called Falcon 1, with a more powerful 3.7-meter diameter launch vehicle named Falcon 5, capable of hauling 4.2 tons to low Earth orbit (LEO) and 1.25 tons to geosynchronous transfer orbit (GTO). The cost of the launch of the Falcon 5 was around $12 million. At liftoff, Falcon 5 would be around 29 meters tall and weigh about 130 tons. Its first stage would be powered by 5 Merlin engines with a combined thrust of 162 tons at liftoff and 192 tons in a vacuum. SpaceX began Falcon development in 2005. Plans called for the construction of 12 Merlin 1B engines throughout the year. However, those plans were revised in September 2005 to address the demands of an undisclosed government customer. SpaceX announced the development of Falcon 9, which would be powered by 9 Merlin 1B first stage engines for $27 million. Falcon 9 could launch more than 9 tons to low Earth orbit (LEO) or more than 3 tons to geosynchronous transfer orbit (GTO). Future versions with parallel Falcon booster strap-ons were expected to be much more powerful. The Falcon 9 S5 would be equipped with 2 Falcon 5 strap-on boosters. 2 Falcon 9 strap-on boosters would be used in the Falcon 9 S9. Falcon 9 is no longer a Delta II class launch vehicle, but has joined the EELV, Evolved Expendable Launch Vehicle payload category. SpaceX received a Commercial Resupply Services (CRS) contract from NASA's Commercial Orbital Transportation Services (COTS) program in 2008 to carry goods to the International Space Station (ISS) using the Falcon 9 and Dragon spacecraft. On October 8, 2012, the first mission under this contract launched. As part of the NASA Commercial Crew Dragon Development Program, Falcon 9 has been human-rated for delivering NASA astronauts to the International Space Station. Falcon 9 has been certified as Category 3 for the National Security Space Launch Program and NASA Launch Services Program, allowing it to launch NASA's most expensive, vital and difficult missions. SpaceX reported on 12th November 2007 that it has finished Merlin 1C engine development with a 170-second hot-fire test at its Texas test facility near McGregor, Texas. The development engine test program includes 125 hot-fire tests with a total length of more than 3,000 seconds. At sea level, the first Merlin 1C could generate 43 tons of force and 49 tons in a vacuum. In mid-2007, SpaceX delivered its first Falcon 9 first stage to McGregor. During August, the stage was built onto the company's gigantic Big Falcon test stand. The first Falcon 9 hot fire test, using only one Merlin 1C engine, took place in November 2007. Following this, a 2-engine test was conducted in January 2008, followed by a 3-engine test in early March. SpaceX tested the 9-engine Falcon 9 for the first time at McGregor on November 23, 2008. The burn lasted 178 seconds and generated 387 tons of force while consuming roughly 227 tons of fuel. After 160 seconds, 2 of the 9 Merlin 1C engines shut down as anticipated following the flight shutdown procedure. Residents from more than 20 miles away were frightened by the late evening test. A battleship-style run tank was employed in McGregor testing. SpaceX intended to remove the run tank after the full-duration test and ship the engines to Cape Canaveral, where the first Falcon 9 flying stage was expected to arrive by the end of 2008. The facility testing at SLC-40 was supposed to use that flight stage. The first Falcon 9 flying vehicle stages were accepted for flight testing at McGregor in 2009 and early 2010. On October 5, 2009, both stages' structural acceptance testing was completed. On October 12 and 16, the first stage was fired for 10 seconds and 30 seconds, respectively, to complete its testing schedule. In November of 2009, the stage was delivered to Cape Canaveral. On December 8, 2010, the company's Dragon C1 spacecraft was successfully launched into orbit by the second SpaceX Falcon 9 rocket, launched from Cape Canaveral at 15:43 UTC. The 2-stage, 313-ton kerosene LOX rocket launched from Space Launch Complex 40. Dragon C1 detached from Falcon 9's second stage after a roughly 9-minute propulsion phase and a 20-second coast, leaving just the trunk segment intact. The rocket was finally launched in 2015 after several testing in the preceding years. Falcon 9 set a new record for the most satellites launched by a single rocket on January 24, 2021, when it sent 143 satellites into orbit. SpaceX intends to someday replace the Falcon 9 and Falcon Heavy launch systems with the considerably bigger Starship launch vehicle, which is currently in development. After 7 hard years, the spacecraft has finally arrived at the Moon, where it will crash into its surface, after completing a long engine burn and carrying NASA's Deep Space Climate Observatory on its route to the Lagrange point. The rocket's second stage became debris. Lagrange points to a gravity-neutral position 4 times further than the Moon and in direct line with the Sun. According to meteorologist Eric Berger in a recent story on Ars Technica, it was high enough that it didn't have enough fuel to return to Earth's atmosphere, but also lacked the energy to escape the gravity of the Earth-Moon system. As a result, Elon Musk and his colleagues decided to crash the rocket onto the Moon. This will, at the very least, assist scientists all around the world in gaining a better understanding of the lunar surface. It's the first time this has happened. After a few near misses, NASA too knowingly crashed several of its Ranger spacecraft onto the Moon in 1964 to transmit back photographs of the lunar surface moments before impact. Although, apart from our thoughts, what are your views on this blow? Do you think it is happening because SpaceX is being careless? Let us know in the comments below, and also subscribe to our channel and hit the bell icon as we bring you all the exclusive news about Elon Musk. Thank you for watching. We'll see you in the next one. Until then, peace.